All right, let's do some notes. 3.3. So we're going out of order. I probably already told you this in class, but we're going out of order because I knew I wasn't going to be here today. So this is called standard form of a quadratic. Ax squared plus bx plus c. A, b, and c are real numbers. If a is equal to 0, meaning that whole thing is gone, then we have just a linear function, not a quadratic function anymore. So that's why a can't equal 0. And we'll talk about this a little bit more later. When that number a is positive, the parabola opens up. And when that number a is negative, the parabola opens down. You remember that from Algebra 1, I'm sure. The vertical line passing through the vertex is called the axis of symmetry. So you probably remember this from Algebra 1 also, and Algebra 2. The equation for the axis of symmetry is x equals negative b over 2a, and that is the same as the x value for the vertex. So that's two birds with one stone. So let's apply that. Find the vertex and axis equation of the axis of symmetry for this function. So we're going to go x equals negative b, right, over 2a, and that's going to give me negative 8 over 4. So the axis of symmetry is x equals negative 2. And I also know the vertex x coordinate is negative 2 using these two pieces of information here. So then how do I find the y coordinate? I plug that number into the equation. So f of negative 2, right? So replacing the x's with negative 2, and then PEMDAS, make sure you're always thinking PEMDAS, exponents before multiplying, and then addition and subtraction from left to right. So my y coordinate is negative 3. Easy, right? Okay, so super simple Algebra 1 review. All right, this is not super simple Algebra 1 review. Convert to vertex form. So this is vertex form. We said this was standard form up here, and then this is vertex form down here. And we'll talk about why that's helpful in the next example, but first let's figure out how to get it there. Notice the x is by itself, it doesn't have a number attached to it. So the first thing we need to do is take out a 2, and you're gonna think this looks weird for a second, but I'm gonna write it like this. So I wanna have the stuff with x's, I wanna have together. And then the thing that doesn't have an x is just going to float on the outside for a second. So notice I took the 2 out of both of these things, right? And if I were distributing it back in, I would get those. And then the plus 5 is not attached to the 2. I'm just keeping it a plus 5. So then now, do you remember completing the square? Completing the square, we take the b value, we divide it by 2, so do that in your head. And then we square it. So 4 divided by 2, and then squared. That gives me plus 4, right? So write yourself a note right now. I'm going to give you a second, actually, to write yourself a note that we did b divided by 2, put parentheses around that, and then square the whole thing. And then maybe draw like an arrow to this or something, okay? Now, I can't just willy-nilly add something where I want. Usually I would add it to both sides, but I don't want to have something hanging out over here. That would look weird, wouldn't it? If I had f of x plus 4 equals all of that stuff, that would just look weird. So I'm not going to do it on both sides. What I'm going to do is I'm going to add it and then subtract it. And you're like, well, that's just silly. That's crazy talk. Why would you do that? You'll see in a second. So first thing, instead of adding to both sides like we've been doing our whole lives to balance the equation, we're going to add and subtract. So you agree that that's going to balance it out, right? Second thing is I can't just add 4 here because I didn't just add 4 here. I added 2 times 4. Think of it as if I simplified this, I'd have 2x squared plus 8x plus 8. So to undo this plus 8 right here, I need to subtract the same thing. 2 times 4. Okay? So now basically what I did in this kind of pinkish orange color is absolutely nothing. I added 8 and then I subtracted 8. Okay? Here's why I want to do that. Why do I want to do nothing? Because this now factors. What multiplies to 4 and also adds to 4? Maybe you're still doing this, which is fine. 2 and 2, which means x plus 2 times x plus 2. So every time you complete the square here, you should get a perfect square there. That's why it's called completing the square. You've done something, adding this number to create a perfect square. Okay? And then I don't want to forget about the stuff at the end. So this stuff makes -3, right? 5 minus 8. So -3. Now I have it in vertex form. Doesn't that look just like that? So that's it for this problem. All they asked me to do was convert. So in the next problem, we're going to see why we care about vertex form. Okay? So in this problem, I can graph this using transformations. So my parent graph is y equals x squared, and hopefully you have all these points memorized, right, for y equals x squared. So I'm going to plot those. And then I'm going to, now when I'm doing transformations, when there's multiple transformations like this, I need to think PEMDAS. So the first thing I'm going to do is the parentheses. The very first thing I'm going to do is the parentheses. So when I have a plus 2 on the inside of the parentheses, I'm going to move left 2. So each point, 1, 2, get rid of it, 1, 2, get rid of it, 1, 2, get rid of it. Then I've got multiplication and subtraction. Multiplication comes next. This tells me to multiply the y values by 2. So this point right here has a y value of 1. The x stays the same, but I multiply the y by 2 to get 2. This point has a y value of 0. 0 times anything stays the same. And then same thing here. This one has a y value of 1. 1 times 2 is 2, so the new y value is 2. Okay? If you want to, instead of crossing off the points, you can erase them, but I think it's good for your notes to see the work. And then the last thing that we're going to do is the subtraction, right? PEMDAS. So I'm going to subtract. I'm going to take care of that subtracting 3, which tells me to move all of my points down 3. So from there, 1, 2, 3, 1, 2, 3, and 1, 2, 3, and then connect the dots. Make sure your graph is a U-shaped curve, right? Not a V shape. U-shaped curve, and that's it. So that's why vertex form is helpful, because it makes it easier to graph. We're going to talk about graphing when it's not in vertex form another time, but trust me, it's yucky, okay? So here's just some review. This whole chapter, honestly, is review, except for one thing that we're going to be doing on the graphing calculators or on Desmos. But just a little summary here. The discriminant is that thing that's under the radical in the quadratic formula. It's called the radicand. If that thing is greater than 0, that means we have 2 solutions. Remember, solutions are the same as roots, are the same as zeros, are the same as x-intercepts. Okay, and this is what it would look like. If with that thing is equal to 0, then we only have 1, and this is what it would look like. And if that thing is less than 0, then we have no real solutions, and that's what it would look like, no x-intercepts. Okay. How do we find x-intercepts? Remember, we replace y with 0 and solve for x. Usually when we have some kind of quadratic like this guy right here, the y would be 0. We would factor this to solve for x. Sometimes we have to use the quadratic formula to solve for x if it doesn't factor. So what we want to do is when we're doing this, our first line of defense is to factor, because factoring is 99.9% of the time the easiest method. Then if we can't factor, then we might want to probably complete the square in certain cases. And if we don't remember how to complete the square, or we don't want to complete the square, we can do quadratic formula. We'll review completing the square another day, but we completed the square in this problem here, right? Just not in a solving capacity, but in a converting capacity. So here's the quadratic formula. Hopefully you remember that cute little song or whatever. And then on the homework tonight, your book is going to ask you to graph. There's two sets of problems. One is using transformations, which is what we did in example 3. The other one is what I was talking about, using the vertex, axis of symmetry, and intercepts. So if I was asked to graph this problem here, for example, I would plot the vertex on the graph, left 2, down 3. And then I would find the x-intercepts and I would plot those, and then I would make my U-shaped curve. Okay? So that's what this is talking about here. If it specifically asks you to graph using the vertex, axis of symmetry, and intercepts, and you think it's easier to complete the square to get the problem into vertex form, I'm totally okay with that, because that's actually a better skill set to have. It's going to help you more in the future. So here are the steps that you're going to use when you're asked to use method 2 for graphing. Ask yourself if it opens up or down. We talked about that at the very top of the first page. Find the axis of symmetry. That was example 1, and the vertex. Find the x-intercepts. We talked about right here. Find the y-intercept. Hopefully you remember how to do that, because you've been doing that for like 800 years. If you don't remember how to find the y-intercept, I want to challenge you. If you don't remember how to find the y-intercept, ask your neighbor for a hint. And then you're going to connect those dots in a U-shaped curve. All right. Have a good weekend. I will see you on Monday.